Welcome back again. This is Avilas Sarkar in Bal Vigyan Bharati channel, and we are moving on to the problem number 37 on speed, time, and distance. It says P cycles at a speed of 4 meter per second for 8 seconds, 5 meter per second for 8 seconds, 6 meter per second for 8 seconds, and so on and so on. Q cycles at a constant speed of 6.5 meter per second throughout. If P and Q had to cycle 436 meter race, how much lead in terms of distance can P give Q and still finish at the same time. Okay. Now, solution. P cycles at a speed of a varying speed. For every 8 seconds, he is changing his speed, and so on. Whereas Q cycles at a constant speed throughout the track. If P and Q had a cycle of, means they are in a race, whereas this distance to cover is 436, P and Q both start from let's say this is station M or A or B, you can say. I am assuming, that is not mentioned, assuming two terminal of the track, and it's not said that they have started in the same time, so they have started from same place at least. It has to be like that, and P has a varying speed whereas Q has a constant speed. They have to move this much. Now condition is that how much lead in terms of distances P give to Q. That means P will start later. By that time Q can move some distance, or else Q can start from some point which is forward to P, and then P will start keeping this distance, initial distance, let's say some distance x, and they will reach at some point. That means this is as well as good as some relative distance of x has to be covered by the relative speed of P and Q, and they will reach at point. So this, if I consider time is same, so this distance is covered by their relative speed and they will reach at some time. So this is can be read in same way, but calculating relative speed in this case is very difficult because p is having variable speed. So we can go within some other way so that we can reach some conclusion. So how can I reach? So respective distance, if I calculate in each case how much he is moving. So if d1, because total distance we know that much has to be covered. So now if I say that 4 meter into 8 seconds, that will cover 32 meter. Okay, and we can do also respective distance, we can go on deducting. So what is the remaining? That is 30404. Now d2 is 5 into 4 5 into 8 40. This is the second, so we can further reduce it by deducting this. That will be how much? 4 36. d3 is how much? 6 into 8 48. So if further deduct 48, will get how much? 16 316. d4, then after this is a 4 5 6 7 7 into 8 56. Deduct it 56, I will get how much? 260, I suppose. Yes, 260. d4, this is 7, I have raised 8 64. So 260 minus 64 196. d5, this is 8 9 72. 196 minus 72, how much? 4. Okay, now d6, how much? 70, this is 9 10 80. So this will be 124 minus 80, that will be 44. Now see, if I go d7 whole distance, this will be 11 into 88, that means 88, but this is higher than this. So further this much distance will remain when he has moved already how much? Total 44. If I deduct, this is 2, this is 9, 2 13 9 392 distance already moved by A, when the remaining distance is only 44. Okay. So this is up to 10th speed he has geared up, 4 to 10. So remaining means, so the time taken for him, so now fine, this is the 10th. 10th is covered 8 into 4 5 6 7 8 9 10. So 7 into 56. This is in second. 56 seconds is already moved by A. By his in this time he has reached, because 4 into 8 5 into 8. So that way how much we did? 10 into 8. So 1 2 4 5 6 7 8 9 10. 7 time of that 8 has moved 56, and remaining for 44. How much time will take? In that time the speed is how much? 10 to 11, geared up 11. So with the 11 he will take another 4 seconds to move. So all in all, how much speed how much time he will take? The total time will be 56 plus this 4, that means 60 seconds he will move from this to this. Okay, now how much the other one Q will take? This is P, and for Q it is constant speed. Now for him, for Q, 6.5 meter per second. If you want to move that 436 with 6.5, now and this that 60 seconds he will move from to this, and he will take how much? This is if I calculate 65 0, so that will be how much? 4, if I take 13 5, 13 3, 4 6, 13 3, 4 6, so that means 13 3 again. This will not be cancelled out, so how much? 6.5 by 436 meter, so 436 divided by 6.5 meter per second, so that will give you the second. So this is equal to 0, 65 is equal to 5, 13, 5, 8, 5, 7, 5, 2. So let we divided 6, 872 divided by 13, 78 is equal to how much? 9, 2, 6. This is equal to 79, 91, and 1 will remain. So this will be around 67, 67.1, around 67, 1/3 I can say. This much time he will take, Q will take to move this one. But as I know that that total time, if it is taking this much, I need to post somewhere Q, so that he has an advantage of this 7 and 67 1 and 67 1 by 13 minus 60, that P is taking to cover from this to this. He has to have an advantage of 7.5 seconds, so that he can lead this much, so that both can come together, because this is the condition, how much lead times distance P gives Q, so that they still finish at same time. To finish the same time, Q must be somewhere from where he can reach in 60 seconds to the terminal. So advantage of time has to be this much. So in that time, how much Q can move? That Q can move is equal to 6.5 into 7 and this much. So this is 6.5 into 92 by 13. So this is, if I say 1310, 13.5, and this is equal to 5.2, and this is equal to 46. So 46 meter. So he has to have a distance x is equal to 46 meter. He has to give a lead to Q. He has to give a lead to Q. Then they will reach together at the terminal. Understood? Now moving on to the problem number 38. A bus starts from a bus stop P and goes to another bus stop Q. In between P and Q there is a bridge AB of certain length. A man is standing at a point C on the bridge. At a point C on the bridge, such that AC is to CB is equal to 1:3. When the bus starts at P and if the man starts running, and if the man starts running towards A, he will meet the bus at A. But if he runs towards B, the bus will overtake him at B. Which will be suitable condition? What will be suitable result? Not condition, which will be suitable result. Actually, this is not the finish line of the question. There is a option is given, but instead I kept it like that so that student can think of their own. They should not work being confused by giving options. So I have not kept any options. There are 4 options so there in the question, but I took like that so that people can think freshly without any guidance of the options. Sometimes options is helpful, but sometimes it is also confusing. So I have not kept the options. Rather, I kept what will be the suitable results. Means what is the respective. The options was respective speed of the bus and the man. It is given. There are 4 options given. Instead that, if you keep yourself without any clue, your thought process may be very fresh. Okay. So now just draw the picture. A bus starts from a bus stop P. So this is a bus stop. Let's say this is being denoted as P, and between P and Q there is a 2 bus stop. Let's say this is P and Q. These are bus stop. There is a bridge AB. That means when they are moving, there is a, let's say, a bridge. I am talking about this bridge having AB. This is named as AB. Okay, fine. A certain length. This length is not set. Let B. This is B something. I am not writing. So length, a man is standing on the point C. Let's say the man is standing at C. This is another point C on the bridge. C on the bridge such that AC is to CB. That means this distance is to CB is 1:3. So I can assume this is X. So then this is 3X. That is easy to represent the length. Then the total length will be 4X. Okay. When the bus starts from P, the bus starting from P, if the man starts running towards A, then on the first case, this is case 1. There are two cases I can see. This case 1, when the man starts running towards A, this man is there first, he is moving towards A. Okay, the A is there, the beach terminal, this is another terminal. When he is moving this way, the man moves this way. So, if I assume the bus speed is B, let's say B, and man speed is M. This could be the speed I can assume, because this is the unknown thing that is not known. Okay, and the distance is not said in the bus stop. P and Q goes another way. In between the PQ there is a bridge. Okay, so the distance between P and Q is not said. Okay, but there is a bridge in between somewhere. I don't know the location. So fine. So when the first case P and the man starts running towards A, he will meet the bus at A. So both will reach, means man starting from C will reach A, and as well as this will reach P. So they are covering some distance. Let's say this is my Y distance. This could be another Z we can take, let's say. So when the first case, when man and bus are in opposite direction, so these are opposite direction. So what is the distance they are covering? Y plus X. This is the relative distance between them, because man was standing in C and P was starting from B was, the bus is starting from P. So this is the relative distance divided by their relative speed is what? I assume it is B, this is M. So they are opposite direction. So B plus M will be the relative. So and time is what? Time is the taken, time is taken is when they meet. So instead of that, there is no other equation I can create. So what I will say, that in the time when bus will reach here, he will cover a distance of Y with his speed B, that must be equal to how much? The man is covering X distance with his speed M. This will be the case. Okay, because they are moving and they are reaching at some point in same time. The time is same, that means distance by the speed, distance by the speed for the first equation. Okay, because I don't know the distance. And for case 2, what is the case 2? When man is moving up towards B, and okay, P, if the man starts running towards A, that is the first case. But if he runs towards B, the condition is what? Bus will overtake him at B here. So the second time the bus will move Y plus this 4X distance, whereas man will move 3X distance. So Y plus 4X is moved by the bus with his speed B, that is equal to the man is moving 3X with his speed M, isn't it? So then only they can reach there. That means overtaking means at least they can touch each other, then after bus will move on. So at that point they will be in the same location. Fine. So whether if you are able to calculate this too, any other equation is possible now. So what is y, uh, what will be the suitable condition. So let me check if we can represent this. Y is can be obsolete by xb by m. So I am doing that. X by m into b plus 4x this side. I am putting it in second equation. The value of y from first equation putting in second equation is equal to 3x by m into this b will go that side. Okay. Now if I solve it, x is everywhere, so x can be cancelled out. So ultimately b by m plus 4 is equal to 3b by m. So ultimately 2b by m is equal to 4, that is equal to 2. So b by m is equal to 2. So now there we can see some relation is being established. The speed of bus by speed of man is 2:1. So the bus speed is twice the man speed. So that is the only relation that can be built. So in options also there, that was one of the option. So without seeing the option, we can calculate that bus speed is the twice of the man's speed. Okay, so that this is your answer. So I will move on to the problem number 39. Okay, now this is problem number 39. Okay, the problem number 39 says Ramesh take 6.5 hours to go from city A to city B. To go from city A to B at 3 different speeds, at 3 different speeds, 30, 45 and 60 kmph, covering the same distance with each speed, covering same distance with each speed. Okay, the respective mileage, the respective mileage per liter of fuel are 11 kilometer, 14 kilometer and 18 kilometer for the above speed. For the above speed, Ramesh's friend Arun is an efficient driver and wants to minimize his friend's car's fuel consumption. So he decides to drive. From city A to B. how much fuel will he able to save? How much fuel he will able to save? Okay, fine. So Ramesh takes 6.5 hours to go to from city. Let's say this is two cities, city A, city B, three different speeds. So that means if I divide this journey in three different segments, so this is 30, this is 45, this is 60 kilometer per hour kmph. He is moving. He means Ramesh is able to move covering same distance. That means all three distance, if I say if total is d, so it is d by 3. Now time taken, the first thing I can calculate without even seeing the question. D is unknown, so d may be useful, so d I can calculate here. D by 3 by 30, this is the speed, this is the time taken for this segment, and for next segment it is 45, and then next segment is d3 by 60. So this is d by 90 plus d by 135 plus d by 180. Okay, so fine. So these are the case, so d has to be calculated. Now this is 6.5 hours, these are on kilometers, so d is how much? All these have to be added. What is the LCM? 90, 135, 180. If I take this 15 will be the 15, 6, 15, 90, then 45, 3 times 6 and 3, 9, and then 15 is equal to 1, 2, 12. Then further 3, 2, 3, 4, then 2, 1, 3, 2, 2 to the 6, 6 to the 12, 12 into 15 is 180, 180 into 3, 480, 180 into 3 is equal to 540, sorry, 540. This is 6.5 into 90 into, no, it should not be 90, this is 540, and then below 540, that means 90 into 6, 90 into 6, 6 will be there, 135 into how much? 135 means 4, and plus 180 into 3, 3. So all total is 10, 13. So that means 6.5 into, so this is 54 by 13. 5. 54 means how much? 22, 5 is 22, 270 is equal to 5 into 54, that is 20, 5 into 20, 270. So D is your 270, that is calculated. Okay, now I will rub it out. So D is your 270. So I will write it here. D is equal to 270. Okay, this is kilometer. Now what would be my requirement? D by 3 gone in 30 kilometers, and there are some fuel consumption also we can written. Respective mileage per liter is 11. So for first case D by 3, this means 90. So all are 90 kilometer is moving in each segment. So first 90 with this fuel cost will be how much by 90? This will be the case. Second case, 90 by 14 will be the fuel consumption, that will be and that is equal to 90 by 18 is the fuel consumption. Now this 90 is equal to how much? 8 2 by 11 plus this is 14 means, or if I calculate in decimal approximation, to be 8 11 1 then 8 plus 14 6 14 4 14 almost 3 plus 18 5. So almost how much? 5 11 19 and the decimal 11 5 and 6, almost this much of liter if Ramesh drives. Now it has said that Ramesh friends Arun is an efficient driver. So what an efficient driver could do, if these are only the options when he can move with these speeds to save fuel, you know what is the means fuel consumption is equal to the distance divided by the speed. Now if distance is constant, to save fuel you have to be speed up your vehicle. So if these are the only possible speeds are available to the person who is efficient driver, he will try to move it in the high speed. There is no restriction, so he will move whole distance with 60. So for him if he moves with the 60, your fuel cost is how much? For him it is 90 by 18, means for that 18 kilometer per liter. So this is 5 liter is consuming for what? In 1 liter 90 kilometer 5 kilometer per liter is consuming. So for Ramesh the means kilometer per liter was this much in liter. So he can move 90 kilometer in 18 kilometer per liter. So this is the liter consumption. So this is liter consumption. This is liter consumption for whole journey for Ramesh. I want to distinguish the case. So this is the Ramesh liter consumption for the whole journey. Whereas if you can speed up to 80 and with the constant speed of 80 you can move the high speed, the friend Arun. So Arun's consumption will be how much? For him the distance is how much? D is equal to 270, and if he can move with the 60 km per hour, so 60 km per hour per liter can be moved with 18 per liter is 18 so not 60 kilometers. If he moves with 60 kilometer, he will consume how much liter? This is 270 kilometer by 18, because this is the total distance to be covered and this is kilometer per liter. This is the for high speed he will consume this much. So this is total kilometer per hour. This will be the consumption for Arun. So this is how much? 92930. This is equal to 15. So he will consume 15 liter. If he is an efficient driver, he will move with a high speed. That is for sure, and he will consume 15. So how much fuel he can save? This is 19.61 minus 15. That means almost 4.61 liter he can save for his friend. Okay, if he is an efficient driver, he will move with that is the concept, he will move with the highest available speed, because there may be other speed, but as per the question there is no other option, only the 3 speed is available that his car can move with. Okay, so here I will end up this session. I will start from number 40 in the next episode. So this will be my count from where I will start again. Okay, so thank you for now.